In this video, I'm going to demonstrate how to convert by using the factor label method, because one of the issues that sometimes students will have is that even when they know the conversion factor, they know, like, for instance, like there's so many minutes in an hour and so many seconds in a minute, they'll start having difficulty knowing, well, should I be multiplying this or dividing this? And it gets a little confusing and they end up doing the wrong operation. If you use the factor label method, you're always putting the values in the numerator or denominator based off of what you're trying to cancel and what you're trying to go towards, and that lets you ultimately see what you're multiplying, what you're dividing, and end up doing the right operation. So here you're asked to convert this to seconds and you're given 14 hours. Well, depending on what conversions you happen to know, and sometimes you're going to see that the homework problems, they might give you the hints and give you some of the conversions that you need to work with. They're not always going to give you the conversion that goes directly to what you're looking for. As I mentioned before, we know how many minutes are in an hour, we know how many seconds are in a minute, so what I can first do is convert this to minutes by multiplying this by 60 minutes over 1 hour, because what that's going to do is, because essentially this was originally in the numerator, because there was no denominator shown. We assume there's a denominator of 1 in those instances, so this hours was in the numerator. We wanted that unit to go away and we replaced it with minutes, so we canceled it by putting 1 hour down here, 60 minutes up here. This fraction, you have two different units involved, but this fraction is essentially equal to 1. So we multiplied this by 1. Although the number is going to change, the quantity is still the same. Because whatever 14 times 60 is, that number of minutes is the same thing as 14 hours. So you're not changing the quantity, you're just changing the value based off of the units being used. Now, to go from minutes to seconds, because ultimately we want seconds. Well, we know there's 60 seconds in 1 minute. This would cause the minutes to cancel, and now you're with seconds, the unit you want to end up with. Again, this fraction was equal to 1, because these are equal values. And so, in order to come up with the right answer, you're going to take 14 times 60 times 60 again, and that's going to give you 50,400 seconds. So that makes it less confusing as to what gets multiplied, what gets divided. It really depends on how you set up the fractions and what unit you're trying to cancel and what unit you're trying to end up with. This can be done no matter what kind of situation you have. For instance, we want to convert this to miles. 8.3 times 10 to the 5th centimeters. That's a lot of centimeters, but what is that in miles? So not only are you converting from metric to standard measurements, but you're also dealing with some scientific notation. Is a really big number here, but we don't have to worry about the scientific notation part, at least not yet. You're not going to find most places, unless you Google it, which you won't be able to do during a quiz or a test, or in the standard conversions, you're not going to find it. It goes from centimeters to miles, or how many centimeters are in a mile, but there are 2.54 centimeters in an inch, and that at least will go from metric into standard. Now the 1 inch goes on top and the 2.54 centimeters goes on the bottom, because again we're assuming that this is all in the numerator and we want the centimeters to cancel. So now this would give us inches. Now we can go from inches to feet. We know that there are 12 inches in 1 foot. The inches go in the denominator, the 1 foot goes in the numerator. And a standard conversion you might be given is that there are 5,280 feet in a mile. So you're going to multiply this by 1 mile over 5,280 feet. This would cancel the feet because you have this in the denominator. This would give you the number of miles. So basically you're going to take this number, 8.3 times 10 to the 5th, you're going to divide by 2.54, then by 12, and then by 5,280, or you could also think of it as dividing by the product of these. So you could multiply these three together and then take this number divided by that product. If you do that, you get approximately 5.16 miles whenever you round to 2 decimal places. This can be done in situations where you're going from a unit of measure that deals with rates of change as well. So in the next example, you're told a factory is able to produce 58 widgets every minute. Each widget is worth $15. What is the value of the production of widgets at the end of a 10-hour production day? So they have some convergence here. You have 58 widgets for every minute. You have $15 for every widget. But what you're starting with here are 10 hours of production time. So that's what you're starting with. You ultimately want to find, because it's asking you for the value of the production, you want to find the end result in dollars. So we're starting with hours here, and we want to end up with dollars. So starting with 10 hours, we want to start using the information in this problem to convert. Now, the thing is, we have 58 widgets for every minute. We have hours here, so this probably needs to be converted to minutes. So converting this to minutes, 60 minutes in 1 hour. So now we have the quantity of time that we have for our production day in minutes. Now we have a conversion that's being given here. 58 widgets over 1 minute. This will now take us from number of minutes to widgets, whatever they are. Now that we know the number of widgets, well, we know each widget is worth $15. So that's going to take us from widgets to dollars. And dollars is what we want to end up with. So here you're going to take 10 times 60 times 58 times 15, and you're going to get $522,000 worth of widgets. And so that is the end of this problem and the end of this demonstration. If you have any additional questions, please bring them up during class, but go ahead and try the examples that follow this demonstration to see if you're catching on with using the factor label method.